Good morning. Today we are going to discuss about two concepts called binary classification and the multi-class classification. Before going to see about binary classification and the multi-class classification, we go back to a concept called supervised learning. What is the supervised learning? We will see. And what are the categories of the supervised learning? And what can be a classification, and what can be a binary classification, and what is a multi-class classification. Supervised learning, it is a model that trains on labeled data. Trains on labeled data. Okay, so this is supervised learning. It has two categories like classification and regression. Okay, so classification can be classification in the classification whenever it follows, we are using the classification when the labels are discrete. So regression, we are using the regression when the labels are continuous. So this is about the categories of the supervised learning. Classification and the regression. So classification can be used when the labels are in discrete nature or a categorical data, and regression can be used when the labels are in continuous data. Okay, so the best some of the examples for the classification are suppose you consider a email spam filter. Okay, so whether a email can be a spam or ham. The spam means a suspicious mail and ham means unsuspicious mails. You can classify whether a mail can be a ham email or a spam email. So coming to the regression, so if you want to find whether a height of a person, so it can be 5 feet 6 inches like this way. So it can be called, this is one of the examples for the regression, or weight of the person, or so some of the examples of the regression are like this. So now, what can be a binary classification and what can be a multi-class classification? So binary classification means only two class labels. Two class labels can be used to classify the data. Two class labels can be used here, and in the multi-class classification, more than two class labels can be used here. Here we are using more than two class labels. So you may ask one question that what can be a label and what can be a feature. A feature can be an input data and a label can be an output data. Generally, we are going to consider a feature can be an input data and a label can be an output data. Now we try to see about. So what can be the accuracy? Accuracy of binary class classifier. So before going to see or before going to find about the binary class classifier, let me consider one feature thing. Suppose I have a model that perfectly that classifies an email, whether an email can be a spam email or a ham email. Suppose that email spam filtering, consider just for example, consider two words like lottery and a job and free job. Lottery and the free job. Suppose the words, if a mail containing the word containing the free job, it may be the spam filter may treat that it can be a spam, otherwise it can tell that it can be a ham email. Suppose I am going to take a feature tree here. Suppose my email containing the word called lottery. Whenever a word called lottery is there in my email spam filter finds that there is the email percentage or email can be a spam email and email can be a ham email. Okay, so it can be considered. So 20 spam emails are there and 10 ham emails are there. Suppose if the word containing the lottery, and suppose if the word doesn't contain the lottery in the email, it may check about whether it has a free job or not. Okay, so if the free job is there, then the spam emails can be 10 and the ham emails can be 5, just for example. And if the free job word is not there, then the spam email is 20 and ham emails can be 40. My classifier classifies emails like based on the words lottery and the free job. Okay, so by observing this feature tree, you can tell that my classifier predicts that these can be the correctly classified. Okay, so these can be predicted as positive. So before going to tell about a spam email, we are going to consider spam can be a positive, and we are going to consider spam can be positive, and ham email can be the negative. Okay, ham can be the negative. Ham can be the negative. Spam can be the positive. We are going to represent a spam email as a positive and ham email as a negative. Okay, so by observing this feature tree, we can tell that these two things, these two children can be considered as predicted as positive. Predicted as positive. This one and this one. Predicted as positive. So how do we tell that these two things can be considered predicted as positive? Since it has more number of spam emails. Okay, and this can be considered as, this can be predicted as negative. Predicted as negative. This suppose if an email doesn't contain the word lottery or it doesn't contain the word called free job, there may be spam of 20 emails can be there and 40 number of ham emails are there. So this can be predicted as negative. Since I am going to consider that a spam email can be represented as the positive and ham email can be represented as the negative. Okay. Now by observing this feature tree, we are going to find the accuracy of the accuracy of this classification. Okay. So how we are going to find the accuracy? Okay. So to find the accuracy, we need to use you need to consider a contingency table. Contingency table. Otherwise, we can call it as confusion matrix. And contingency table or the confusion matrix. So how do we find the contingency table or the confusion matrix? Suppose we are going to find that we are going to take predicted positive and predicted negative and actual positive and actual negative. Okay, by observing this tree, you can tell that what are these values. Okay, so here actually the predicted as positives are this one and this one. Okay, the actual values can be, suppose this gives the actual positives and the predicted positives. Okay, so by observing this feature tree, you can tell that the value of this actual predictive and actual plus actual positive and the predicted positives can be 30. So how this 30 number came here? Okay, so predicted positives can be these two can be gives the predicted positive emails. So this can be the predicted positive and this can be the predicted positive here. And the actual positive means, so what can be the actual positives? You can go to consider the spam emails. So what are the number of spam emails here? 20 plus 10, that can be the 30. Okay, and coming to see that actual negative. And what are the actual negative values that can be correctly printed as the positive values? Okay, so this can be considered 15. So how this can be given 15? How this can be given 15 means, so these two can be printed as the positive, right? So printed positive, and the actual negatives can be the hand can be represented as the negative, right? So 5 plus 10 gives the 15. So okay, and coming to see this these values, actual positive and the printed negative value. So printed negative can be represented by considering this node, and by observing this node, you can tell that this can be the predictive node and the actual positive. So what can be the positive value spam? So this can be the 20, and this can be the 40. Okay, so this can be called as the contingency table or the confusion matrix. By observing this contingency table and the confusion matrix, you can find the accuracy. You can find the accuracy. To find the accuracy, you can use the formula called true positives plus true negatives by true positives plus true negatives plus false positives plus false negatives. This one can be the equation. So what can be a true positives here and what can be the true negative, and what can be the false positive and what can be the false negative here. In this table, you can tell that this can be the true positive, okay, and this can be called as the false positive, okay, and this can be called as the false negative, and this can be called as the true negative. Okay, so how this can be treated as the true positive and how this can be called as the false negative, or how this can be considered as the false positive and how this can be considered as the true negative. Okay, so true positive is nothing but, so the actual a positive value correctly printed as the positive can be called as the true positive. Okay, a negative value correctly printed as the positive value can be a negative value falsely printed as the value can be called as the false positive value. Okay, so by observing this table, you can tell that, so 30 plus 40 by, so what are the total values are there? 30 plus 20 plus 15 plus 40. So it actually gives 70 by 100. So the accuracy here can be considered as the 70%. So in this way you can consider the accuracy, or you can calculate the accuracy. Okay. So this is about binary class classification. Now suppose we have the multi-class classification. Okay. So in the binary classification, you can consider two class labels to classify the data, and in the multi-class classification, so two class labels can be, suppose you have given a image to find whether that image containing male or female. Okay, suppose when you consider the multi-class classification, we have so many class labels are there. So more than two class labels are there. Among those class labels you can find. Okay, so this can be, you can classify those data. So this can be called as the multi-class classification. So now what we are going to do is, suppose we have how to handle the multi-class classification. How to handle the multi-class classification, we will see. How a binary classifier turn into multi-class classifier. Okay, so this can be achieved by using two schemes. So those can be called as 1 versus 1 and 1 versus R. Or it has some other name called 1 versus rest. Okay, otherwise it can be called as OVA. Otherwise it can be called as OVO, and this can be called as OVA. Okay, so what this can be? So these two schemes can be explained by using code matrix. So what this code matrix? This code matrix containing elements or numbers called -1, 0 and the +1. Okay, it decomposes, or code matrix decomposes the K class task into L binary class task. Okay, so this is a code matrix. So now we'll see about one versus one scheme and one versus all scheme. So the one versus one scheme. So we explain one versus one scheme by considering three class labels, like three classes like C1, C2, C3. Okay, consider these three classes C1, C2, C3. We can find, or we can learn about one versus one scheme. So in the one versus one scheme, we are going to suppose we are going to consider C1 and we are going to consider C2. One versus one only. Suppose if you consider class C1 and C3 and C2 and C3. So this can be called as one versus one. And again in the one versus one, we have two approaches are there. And this can be called as symmetric approach and asymmetric approach. There are two schemes. Okay, this one can be called as the symmetric scheme. Okay, so how this can be represented by using the code matrix? Suppose C1 class, if C1 can be represented as plus 1 and C2 can be represented as minus 1. So more than two classes are there. Okay, by observing by using the two class, we are going to classify the more than two classes. Okay, and ultimately C3 can be the 0. And if you are going to use the C1 and C3, suppose C1 classified as the plus 1, C1 can be the plus 1, and C3 can be the minus 1, C2 can be the 0. And come to C2, C3. So C2, C3, C2 can be the plus 1, and C3 can be the minus 1, and it can be 0. So this one can be the code matrix. Okay, and coming to see that asymmetric. So this can be symmetric. Symmetric means C1 is, there is no distinction between C1 and C2. But if you consider the asymmetric scheme, there is a distinction between the C1 to C1 to C2 and C2 to C1. So how this can be considered? Suppose plus 1 and minus 1 0, C1 C2, and C2 C1 is not same, right? So C1 C2, this can be minus 1, plus 1 and 0. And coming to say that C1 C3 plus 1, 0 and minus 1, and C3 C1. Okay, C3 C1 can be minus 1, 0, plus 1. And coming to the C2 C3. C2 C3 is not similar to the C3 C2. So that C3 C2 is 0, plus 1, minus 1. Okay, and 0, minus 1, plus 1. So in this way you can represent a scheme in the one versus one. Okay. And coming to see that one versus R or one versus rest. Okay, one versus one. This can be the one versus one. And now we try to say about one versus R. And it is also containing two things like unordered and ordered. So how unordered scheme can be expressed in one versus R. So unordered means suppose C1, C2 and C3 are going to consider three class levels here. Okay. Suppose there is unordered scheme can be represented by, suppose this can be the plus 1 and this can be the minus 1. Suppose they are going to consider, and sorry. So plus 1, C2 minus 1 and C3 minus 1. So this can be the unordered. So we consider one class level as plus 1, remain can be the minus 1. Okay. Suppose if you are going to consider C2 can be the plus 1 So those two things can be the minus 1. Okay, and suppose if you are considering C3 as a positive value, the remaining can be the negatives. So this can be called as the unordered version. And coming to the ordered version, so C1, C2, C3. Okay, suppose you are considering the C1 as positive value and C2 can be the negative value. C2, C3 can be the negative. Okay, and C1, C2, C3. Suppose you are going to consider C2, then you have to neglect the C1. Plus 1 and the minus 1. So this one can be the ordered version of the ordered version. Okay, so in this way we can a binary classification turn into a multi-class classification. Okay, so by using these things we can check that we can do some problems. Like suppose we have given a word here. You have given a word here like minus 1, 0, plus 1. So to which class it belongs to? By using a 1 versus 1 symmetric approach. You can use a 1 versus 1 symmetric approach, and to which class it can belong to. You can directly see that this word can belongs to this class C1, C2. C1, suppose this one is C2 and this can be the C3. So minus 1, 0, plus 1. So this word belongs to the class C2. Okay. And suppose he has given some other word like 0 plus 1, 0. Consider 1 versus 1 symmetric approach. 1 versus 1 symmetric approach. One versus 1 symmetric approach. 1 versus 1. Okay. So the word to which class the word belongs to, this 0 plus 1, 0. So to find to which class it belongs to, we need to use one formula. So what that formula is, we can use this formula 1 minus Wi Ci whole by 2. The which value gives the lesser number that tells about the class which belongs to this word. Okay, so we will see this problem solution here now. Suppose, so consider the class C1 here. C1 containing plus 1 and 0, and my word is 0 plus 1 and 0. So how this formula can be applied here? Okay, this formula can be applied. This can be the word here, and this can be my class label. Suppose C1. This can be the C1, right? Here, 1 in the 1 versus 1 symmetric. Plus 1, 0. Okay. Now, how what this can be? So how we are going to calculate the distance here? So the minimum distance can be given to which this word can belong to this class. Okay. So how this can be calculated? So 1 minus Wi into Ci. This can be the Wi and this can be the Ci. Okay. So this can be the C1. This can be the C1. Okay. So now 1 into 0. 1 into 0 gives the 0. So totally by 2 plus 1 minus 1 into 1. So 1 plus 1 minus 0 into 0. This is by 2. So what will finally gives 1 by 2 plus 0 plus 1 by 2. Okay. So finally it gives 1. Okay. Similarly, what can be suppose what can be the C2? So consider the class C2 here. So what is the values of class C2? What is minus 1, 0, plus 1. Minus 1, 0, plus 1. The word it can be, this is the word. Okay. So what can be the distance here? So what can be the distance here? The distance can be the distance. So what can be the distance? The distance can be 1 minus 0 into minus 1. That will be the 0 by 2 plus 1 minus 1 into 0, that can be the 2, 0, plus 1 minus 0, 0 into 1, that can be the 0 by 2. So the final value is nothing but 1 by 2 plus 1 by 2 plus 1 by 2. Finally gives the 1.5. Okay. Similarly, we consider the class C3. So what are the values for the class C3 we have? So 0, minus 1, minus 1. 0, minus 1. 0, minus 1, minus 1. So 0, minus 1, minus 1. Okay. So what can be the word here? The word can be the 0 plus 1, 0. So what can be the distance now here? The distance can be, to calculate 1 minus 0 into 0 by 2 plus 1 minus 1 into minus 1. This can be minus 1, this can be plus 1 by 2 plus 1 minus 0 into minus 1 can be the 0. So this can gives, so 1 by 2 plus 1 plus 1 by 2. So finally we will get the value 2. Okay, by observing the distances here, suppose this can be one distance and this can be 1.5 and this can be 2. So whatever the value was less here, that can be considered to this word belongs to that class. So here, whenever we consider the C1, it gives the lesser distance. So that we can tell that this word belongs to class C2. This word belongs to class C1. This word belongs to the class C1. So that in this way we can find that to which class the given word belongs to. Okay. So this is about today's lecture. Thank you very much.